Tammy Colda, an applied mathematician, and this is Unlocking LaTeX Graphics. Today I'll talk about plotting a mathematical function using PGFPLOTS. In prior episodes, I focused on plotting table data from text files. You can always use a table method to plot a function f of x. You could use an external program like MATLAB to evaluate the f of x at a bunch of x values and then save the x values and the f of x values to a table in a file and then use our table method. Obviously, that's a lot of steps if you just want to do a quick plot. Nicely, PGFPLOTS has provided the ability to plot a mathematical expression, and this is what I'll cover today. I'll try to present things in a way that is mostly self-contained, but you may want to watch my other videos on TIXI and PGFPLOTS to understand the nuances. These videos are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Okay, so we're going to be plotting some mathematical expressions. I have our document preamble here. I'm using the packages parskip and full page just to make things look nice. The hyperref package is so that I can link the author name back to the YouTube channel. The key package is PGFPLOTS. You have to do a bit of setup up front. I'll link to prior episodes that talk about this in some detail. Here I'm specifying the compatibility, which is recommended that you always do. I'm setting the compatibility to version 1.17. I'm also using a special modifier, scale only axis, that I recommend you always use. I described this in another episode, and I'll link to that in the show notes. I'm setting the width and height to be 5 by 2.5 inches. I'm setting the default fonts for the title, the axis labels, and the legend. And I'm also setting the default thickness of the plot lines to be ultra thick, just so they're visible on the screen. We're now ready to plot some functions. Let's try to plot the function e to the x. I'll paste some code to get us set up to start plotting our functions. The TIXI picture environment creates the drawing canvas. The axis environment inside of that creates our x and y axes for plotting. I'm currently just setting the title and the x label, but I haven't plotted anything yet. I just have an empty axis waiting. As you can see, that makes a little error message. To plot the function, we use the add plot command just as we would with a table. I'm specifying here that the plot should be red and include marks. You probably wouldn't normally include marks in plotting a math expression, but I'm including them here so that you can see what's going on under the hood. The main difference from what we've seen before with tables is that we have the term expression where we normally would have the term table. Following that, we have a mathematical expression in curly braces where we normally would have the name of the data file. The expression should by default be in terms of the variable x. When we compile this, we see a few things. First, the domain defaults from -5 to 5. We'll talk more about how to change that in the next example. Second, the plot is based on evaluating the function at 25 evenly spaced points on the domain, indicated here by marks. If I want to get more samples to make it smoother, for example, I can add samples equals 50 to the axis options, and now we see when we recompile that there are 50 marks. If I take away the mark equals star option from my add plot, now we just have our nice smooth function. Let's plot another function, this time the natural log of x, and we'll use this to show how to change the domain. I'll create the same setup as before. I create a title, a label for the x-axis, and I'll add my function. So if I look over to the right, I'm plotting the natural log of x. Everything looks okay. The domain is different. You see it only starts at 0 and it goes to 5. I also only have 12 points here rather than the 25 that I expect. What's happened is 13 of the points were outside the domain and it came back as unbounded, and PGFPLOTS just ignored it. If you look through the log file, you'll see messages to that effect buried in there. Let's specify a better domain for this function. I'll say that the domain equals 0.1:10, and now we'll get our function evaluated with 25 points using the domain that I specified. So that's how you use domain to specify your axis. With this one too, I probably want to do more samples, so I'll set that to 100 samples and I'll turn off the marks, and now we see our logarithmic function. Now let's plot the trig function sine and cosine. The way that TIXI implements these expressions is that they expect degrees as input. So I'm going to set the domain to be from minus 360 to positive 360. I'm also going to set the x ticks distant to be 90. That means that we'll have ticks every 90 degrees rather than every 100 because it doesn't really know that it's angles and that 90 makes better sense. I'm creating two plots, sine in orange and cosine in blue. And if we scroll down, we see the results here. The first thing to note is that these curves are quite jagged. This is because there's only 25 samples per plot. So I'll go ahead and use the samples option to increase the number of samples to 100. When I recompile that, it looks much smoother and nicer. Let's show where the functions are evaluated by adding marks to every plot. So I'll do that with this every axis plot, append style mark equals star. So now I see all the places where these have been evaluated. An alternative to specifying the domain and number of samples is to directly specify where the function should be sampled using the samples at option. I want to stress that this completely overrides domain and samples, no matter where in the options it's placed. So for example, I'll put it here and I'll have it sample at minus 180, minus 150, all the way up to 180. And now you see the domain has changed. It no longer goes from minus 360 to 360. It no longer uses 100 samples. It uses this sample at that I specified. One last thing before we end is I want to point out that it is possible to plot these trig functions in terms of radians rather than degrees. If the x is in radians, it just has to be converted to degrees before being passed to the sine or cosine function. And PGFPLOTS and TXE provide the DEG function, which can be used to do that. So let me give you an example here. So I'm going to have x be in radians, and before I call sine and cosine, I'm going to pass x into the DEG function so that it's converted to degrees. Let me compile that so you see how it looks. So now we have from minus 5 to 5, and we've evaluated these two functions. I want to stress that we can actually use pi in specifying the domain and the tick distance. So here I'm going to say that the tick distance is pi over 2. And that the domain is minus pi to pi. Let's see what happens when I compile that. Now we have, it's essentially going from minus 180 to positive 180 degrees. Finally, this is a bit jagged. So again, I'll want to increase my number of samples. I'll make it 100 each. And now we'll get nice smooth functions. I hope you found today's episode on plotting mathematical functions helpful. If you did, please click like or subscribe. If you have TXE or PGFPLOTS questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, that you can purchase at major book retailers. Thanks for watching.